Thank you. I like your hair.
Yeah, that should be.
I usually have it in my computer, especially because I'll have at least 5 desktops, so we could call for at least 20 minutes.
Exactly.
I've never had him.
He's better.
Someone will say that.
You're going to sell it, yeah. No. Yeah, 35 the one to start with. Yeah, the one semester they decide that.
Yeah, maybe.
Alright, well, it's going to be, I guess.
Hey, I think the guinea pigs are like 3505. I like 3505. I thought it was fun. And I thought it was interesting. No, this is the just not. Yeah, 140. It's the same thing. I understand. Or no, this is just for. It is Jeff, but I guess you have your grant out of town. I don't know what's today class.
Oh, go to your all courses.
Okay, so let's start it. This is the data mining class, CS 5540 and CS 6540. Professor for this course is Jeff Phillips, and I'm the TA of this course. My name is Xingyuan Pan. So Jeff is out of town. He's traveling for a conference. So I will cover his first lecture. And also on Wednesday, the other TA, Sunipa, will cover the second lecture. And Jeff will come back from next week. But next Monday is the holiday, the MLK holiday. So the actual lecture, the first lecture given by Jeff is the next Wednesday's lecture. And today I will just cover some of the logistic materials for him and answer some of the questions if you have. And in the second half of today's lecture, I will play a pre-recorded video. So Jeff has already recorded a short video which is about half-hour length, introduce the course material and outline of the whole structure. So in the first half, I will just cover the logistic stuff for this course that you need to pay attention to in order to pass this course. Okay? So the most important thing is the website, so which is shown at the top of the slides right there. So every information are contained in this website. So everything I talk today will also, you can find it on the website, but I will just go through of them briefly together with you guys. So make sure you know this website. And so this is the actual website. If I go to it into the browser, this is what it looks like. It has the instructor and TA's names. So we have, I think, 5 TAs, and each of them have different office hours. I think my name is Xingyuan Pan, and Marion, she's here right now for videotaping and streaming the online lecture. And I'm not sure other TAs are not here or not. If you are here, you can stand up. Probably so there are no other TAs throughout today. Okay, that's fine. So this is the website, and it has a lot of materials. So this here, if you click syllabus, you go to the syllabus. So let's go through the syllabus briefly. So here is the syllabus. Yeah, so some duplicated informations, especially the locations, office locations, and meeting times. So obviously, you guys already know this web page. And then here it just briefly says what is data mining, and in the short video, Jeff will briefly cover this. So I think I will skip this part. And the next part is getting help. So yeah. Oh. Yeah. So yeah. So we have professors and TAs, and we all have office hours. So if you have any questions, you can come to office hours, or you can just talk with us right after the class. About the grading, I think this is the important things that you want to know. So the course coming from, the grade of the course coming from 3 different parts. So there are 45% coming from homeworks, and 45 coming from a project. And then there are 2 tests, one in the midterm and one in the final. So each of them counts only 5% of the grade. So really the major part are the homeworks and the projects. I will go through this when we go to schedules. So collaborations. So you are encouraged to collaborate. You are encouraged to discuss anything. Discuss like the problem, the programs, the codes, the algorithms. But everything you turn in must be written by yourself, including the actual write-ups and the program's code. So you can discuss, but the thing you turn in must be from yourself. For project, it's supposed to be a collaborative project. Each group have 2 to 3 students. So I think what Jeff wants is suggest that 3 students is preferred, but 2 students are also allowed. And 1 student's project is only allowed in very special cases, and I think for that you need to contact Jeff directly. But 2 and 3 are both allowed, and 3 are recommended. So each group has 3 students or 2 for project. And for tests, obviously you cannot collaborate. You must show your own work. And so this is the School of Computing cheating policy. I think they have this, like, if the student is caught cheating on a homework or a project or a test, they will receive a failing grade for this course. And for second time, the student will not allowed to register any future computer science course. Yes, question.
So are tests open box and open notes?
I think the test is open notes, meaning you can bring one sheet of paper, writing whatever you like. But only that paper. So if there is a change, Jeff will announce it. But for now, as I understand, this is the case. So it's open notes. Yeah, so feel free to stop me if you have any other questions. So I just briefly go over this syllabus. Let's go to other part of the website. So we already seen this. So syllabus, we have so I think we don't need this slide actually. Let's just go over the course website. The books, textbook. There's no official required textbook for this course. Jeff have his own notes accompanying every lecture, so that becomes the de facto textbook. And besides that notes, he also have this reference material from two other texts. One is this mining massive data sets. The other is foundation of data sets. They all have links in the course website. These are just reference materials, have some of the overlap with the lecture's contents. But as I said, like the de facto textbook is actually the course notes. Videos. So we will videotape all the lectures. Actually, not only videotape, it will streaming online. But I encourage that you still go to the classroom because you can have interactions with the professors and discussions with your classmates, even though you can find the lecture online. For the prerequisites, in the later part of today's lecture, I will talk about this, so I'll skip it for now. Let's see this schedules. So every lecture topic is listed here with the dates. So the first column is the date. The second column, if you click, goes to Jeff's notes. So for example, if I click this LSH, it goes to the notes written by Jeff. This is like our little textbook. And then you can click videos. I think right now the videos contain previous semester's videos, but as the semester going, I think these will get replaced may get replaced by the current semester recordings. But if not, you can get the current one in the YouTube channel. I think the YouTube channel is let's worry about that. Okay. So let's still go on this. The link, this column, has the reference material from other textbooks and other notes. These are just the reference, have some of the materials. Mostly some proofs that are not specifically covered in the lecture. And then the next one are the assignments. So we have, I think we have six assignments along the semester. And you can already see the deadlines for each assignment. Roughly for every major topic covered in the semester, we have a corresponding homework. And the last column is the project. So instead of just leaving all the work to the end of the semester, the project have several components that have intermediate deadlines. So for example, the first deadline we have for the project is the proposal, which is scheduled due at the end of the January 31st. And then there's a deadline for data collection report, intermediate report, and final report, and there's a final poster for the project. So we will talk about more about project as we go near the deadlines of this part. So today I will not go specifically into each individual component. Maybe I will talk about the first two. So the important thing to know is we have midterm test, interim test, and the final poster presentation. So these 3 days are roughly fixed. So if your schedule has some conflicts with the 3 dates, I think what you want to do is contact Jeff as soon as possible to see if there's a chance to accommodate that. And so midterm test, interim test, and final poster presentations. Make sure you are available at those times. If not, and you still want to take this course, just contact Jeff as soon as possible. All the other lectures, even though they are not required to attend, but highly suggested you actually coming to the classroom. So any questions for this part? So this is the class schedule. So let's go to the project. So there is a document. So if you click any of these things, they all point to the same document describing the requirement for the project. So here is what it looks like. So like I said, there are intermediate deadlines. First one is for proposal. Second one is for data collection. Yeah, so here it also mentions the team size is 302. So I think if you look at the schedule, some of the material are not covered before the early deadlines. Like for example, when you do the proposal or when you do the data report, of course some of the material are not covered yet. So in that case, I think you can just briefly go ahead a little bit. So look at what's on there in the remaining of the semester. See if there are any like techniques you want to try or anything you are interested in, and you can just write them in the proposal. When we actually learn that, and you can actually do the work in the second half of the semester. So that should be okay. And if you have, I think for now you don't worry about that. For the first deadline, the proposal, I think the most important thing is to find your teammates. So think about what project are you interested in, and find your teammates or classmates who have like share the same interest, or you want to be a team together. And also you want to determine like what kind of project. To the extent that when you write the proposal, when Jeff read it, he can, based on your proposal, give you some feedback, like whether this is going to work or it's not likely to work. So you want to think about it early, and even before the deadline, you can contact Jeff about project. I think in this document, the best project is, of course, something you yourself are interested in. Like if you already do some project research work, or you have some hobby which can generate some data, you want to explore some of the ideas, that's the best kind of project coming from your own interest. But if you don't already have, here are some suggested topics, you can find it on this project document. There are several interesting data sets that you can take a look at and see if anyone you are interested in. Yeah, so we have a lot of similar classes, more specifically machine learning, which also require a project. So if you take machine learning in previous semester or in the current semester concurrent with this course, I think you are not allowed to use the same project for both machine learning course and the data mining course. In other words, you cannot just find a data set and build a simple classifier and make it as a project for both classes. I think when we approach the project deadlines, Jeff will explain more about the project, like the scope, what he expects from the project. So I will not cover them today. So let's go back to the slide. This is the slide. So I covered the schedule. So this is an example of the lecture notes. So if you click the second column of the schedule, you get the lecture notes for every lecture. Yeah, so this is just a screenshot for the schedule. Yeah, this is the project document I just showed. And after, so at the end of the semester, you are supposed to prepare a poster that you will present to the whole, I think the whole classroom, the whole class. And here is just a example poster. This is an example poster from a one-person project from, I think, several years ago when there are not so many students. I think these days, the group I expect to have like 2 or 3 students. Okay, so that's roughly cover the logistic materials. Oh, I think one important thing I forgot to mention is the late policy. So we have the homework for the class. So the late policy for this class is you have if you're late for 24 hours, basically 1 day, you lose 10% of your points. So if you turn in one day later, if you get 90%, then your score becomes 81 because you deduct 9 from 90. So if you turn in 2 days later, so 48 hours, you get another 10% deduction. And that's the maximum amount that you can be late. So anything turned in after 48 hours, I think will not be accepted. So you can get 10% for 24 hours, and then another 10% deduction for 48 hours. After that, just not anymore accepted. That's the late policy. And the deadline, I believe, for this is the 2:45 on each day. I think it's just roughly just before the class begins. It's not the end of the day, so you should pay attention to that. And actually, all the homework are managed through this Canvas system. So I hope you already know that from previous class. So every homework are turned in through Canvas, and then the deadline will be enforced on the Canvas system. So, any question about that? Okay. So if there are no questions about the logistics, let's go to the actual material. So I will briefly go through this, and then I will play the pre-recorded video from Jeff. So what is data mining? So this is about how to think about in general in data analytics. So the course has several goals. Intuition and principle for data analytics, like what kind of the structure and patterns do you want to get from the data? And the data could be either like in a clean way, like already in a nice structure, or it could be messy, contains noises or missing data, things like that. You want to convert the actual real-world data to the clean abstract data types so that we can apply data mining algorithm on top of it. And then once we convert the data to a form which is ready to consume, we want to process the data efficiently in a scalability way. So the data size might be very large, so scalability is easier here. And then another goal is to, when you finish this, you are supposed to understand the data mining research papers and get maybe not in every detail, but get the ideas from the papers. And this course is not about how to use data analysis softwares or machine learning softwares. It's not about particular programming language. By the way, the homework will involve programming, and the programming language is not like specific to a particular one. So I think you can choose the one you like. But some assignment might be easier in one language than the other. But there's no like hard limit. For example, some assignment might be easier to do in MATLAB. Others might be easier to do in Python. But if you are like very good at Python, you can do everything in Python or everything in MATLAB or Java, C++. It doesn't matter. So it's not about a specific software library or specific programming language. And yeah, so we will not cover everything, but only cover the basics and give you exposure to more advanced materials. So here are some related classes here at the U, which is related to data mining. So there is a class, machine learning. I think this is also offered in this semester and also in previous semesters. It's about classification problems. So given some data set, you want to predict something like true or false, yes or no, or the team win the sports or lose, or things like that. And machine learning is more about continuous optimization. And this data mining class is more about this discrete optimization. And another relevant class is the AI, the artificial intelligence class, which is also offered in this semester. It's more about interaction with the real world. So you have some problems and you can do some planning, searching, observe the environment and learn and interact with the experiment. So besides these two basic ones, we have some advanced topic classes. So probabilistic learning, I think we have another class here in this semester, probabilistic modeling or something. And then also in this semester, there's a structure prediction class, which is, you can think of structure prediction as an advanced machine learning class, basically, which is also related to data. And then there are natural language processing and clustering classes. I think the last two are not offered in this semester. So NLP and clustering are not offered. But everything else here is also offered in this semester. So you can, if you like these topics, you can consider register one of those. Okay, so yeah, so for this class, we have like 6 or 7 topics and 2 or 3 weeks on each topic. Each topic comes with like a homework. And then we have 2 tests, a midterm and a final, and then course project. So the homework and the course project counts most of your credits. Yes, homework managed through Canvas, no restriction on programming. There might be bonus questions for those registered for 6140, so the graduate students. So these are all managed through Canvas. So you can also, besides coming to the office hours, you can also discuss the materials on the discussion forum on Canvas. And then both instructor and TA and also the fellow students are encouraged to answer the questions. So we can discuss there. Yeah, so here is the web for the videos.
Question?
Yes.
So for the getting help part, if there's a question that's like too specific, can we still email the teach list?
I think there's no teach list. You can. So if you have some private question, let's say you don't want to share with the class,
yeah,
you can still email us, either individual TA or the professor, Jeff Phillips. I don't think we have an email list for this course. Yeah, but you're still suggest coming to class, even if you can find a lecture online. And then finally, if you are interested in research, there's so you can discuss with Jeff about your own research, And you are suggested to come into the data group meeting, which is on Thursday every week. I think that's it. So, are there any other questions? Yeah.
Does he have a list of research projects that have been done in the past that?
Yeah, I think Jeff have some examples. I think when he come back, he can talk about it, like some good example from previous semesters. I don't have them for today though, so yeah. So other question? Yeah.
Do you know when the homework's going to be out?
That I don't know for the first homework. But if it is up, you will get an announcement. So all the announcement will be announced through Canvas. If you subscribe, that you should get an announcement. And also you already know the deadline, so you might want to check it like frequently. Other questions? And if there's no other questions, let me play the videos. Pre-recording.
So welcome to the spring 2018 edition of the data mining class. So I'm sorry I'm not able to be in class today. I also won't be in class on this Wednesday. I'm traveling at an academic conference this week. So hopefully this will be the only, these will be the only lectures that I miss this semester. So thanks for Xinguan for going over the fundamentals of the class today. If you have any further questions about those, if you wasn't able to answer something, please email me. I'll try my best to respond to emails and emails quickly while I'm traveling. And then on Wednesday, so another TA, Sunipa, will be giving a lecture. And so she's my PhD student and is going to do a great job. There are also videos of the class from last year. I believe already linked off the webpage. I'll be kind of updating the videos from the ones we take this year as the semester goes on. So just to add some comments onto what Xinguan was saying about the schedule. It's not totally fixed, so I plan to add a couple or modify a couple lectures this year with some new content. And so I may move around slightly. And the dates of the midterm, the final, and the project poster are probably correct. I will fix those within, whatever they are at the end of this week will be the final setting of them. But I might change them as I examine the schedule going forward. So if you do have any conflicts with those 3 dates, those are kind of the dates that are will be hard to fix. Please let me know now, so we can try and make sure this works before the drop deadline. Also notice the student office hours on the TA office hours on the webpage. If these are kind of all in conflicts with various things that you have, please let us know, and these are not totally fixed in stone, and we'll probably allow for some extensions of these on the weeks before, because I know that's when I'll be finally going to see all the details. Okay, so another question I often get in the first lecture is about, is this class the right class for me? Right, so what the rest of what I plan to do in this video is kind of give an overview of what the class will be about. What is data mining and how do we teach it here in this class? Also questions about the background. We started teaching this kind of Foundations of Data Analysis class for undergraduates a couple of falls ago, in the last 2 falls, and there's now essentially a book online. We don't expect you 100% know all the material, but when we review stuff from that book, it's going to be kind of fairly quick. So keep in mind that there's that extra reference there, which If you're unsure about whether you're a good fit for this class still after this lecture, please email me. We can try and talk over email or other ways before that deadline. I'll be back on Friday if we need to talk in person. Keep in mind also, next week, Monday, there's no class because it's Martin Luther King Day. So my first lecture will be next week, Wednesday. So for the rest of this lecture, I'm going to go through some slides and talk over them, and it will be as exciting as talking over slides is. For most of the rest of the semester, we'll be giving lectures on a tablet where I'm writing out as we go. And I think this can allow the class to be a bit more interactive. Obviously, I can't be too interactive on this video, but I'll strive for that even with a large class. So what is data mining? And this is not a well-defined question. I mean, there's no well-defined answer for this, right? Depends on who you ask, you're going to get a different answer. Does it find structured data? Is it machine learning on large data? Is it unsupervised learning, large-scale computational statistics? You can ask different people, even at this university, and they would maybe give you yes for any of those answers. That's kind of not how we try and frame it in this course. We try and frame it, one, to complement the machine learning course, and two, to kind of be generally about how to think about doing data analytics. So what is data analytics? This is kind of taking messy data and analyzing it in some way, but we're avoiding the classification problem that's studied specifically in machine learning. So there are lots of other issues that are important in this area. So the main thing we'll focus, kind of the three main things we'll focus on are, one is kind of principles for converting kind of raw messy data into these abstract representations. Right? So if you take an algorithms class, or if you read a book of data mining techniques, they're going to say, assume you have a point set, assume you have a graph or a matrix as your initial data, and then here's some algorithms you can run on it, and it gives these results. But that's often not how your data starts out. So what are the challenges in choosing how to define the point set or whatever, or the matrix, one of these abstract representations? So we'll talk about these process of converting into these abstract types. Then once we have these abstract types, or mixed in with this, we'll describe a bunch of different algorithms on how to analyze data. Okay, and so if you're given data, you're asked to find structure in it. There's not like one way of doing it. There are many different ways, and we'll try and survey the kind of the most relevant of these, the most classic of these, and touch on some of it at the state of the art. And even within this, we have to make some choices of what to do. So we will be focusing on those that deal with scalability, deal with error of the data, and deal with kind of some modeling issues. One way I like to think about it is that you can think of these two domains, statistics and algorithms, where algorithms is starting with some well-defined structure and just trying to make it as efficient as possible. You say, give me a specific problem, I'm going to solve it, right? How fast can I do it? And statistics is about, here's some data, how do I determine whether the right structure is there now? What is the right mathematical setup for doing this? But it often doesn't talk at all about how to do that, right? Sometimes it does that, but it's kind of an afterthought, right? And so, some algorithms and statisticians go over this way towards the middle, in either direction. But data mining, as we view it, is going to be somewhere in the middle. It's going to be looking at both of these concerns and trying to figure out how to balance them, right? How do you balance getting as good a model as possible with something that I can compute, and I can compute it at a large scale, right? So there's going to be this tension between these two parts. And maybe you've taken the statistics or an algorithms class, but how to balance these two things is not always obvious, and that's going to kind of be the main focus, one of the central themes of this course. Okay, and then said each university will teach data mining differently, right? So this is how we define data mining in this university and in this department. What we do, beyond what I described, is we're going to focus on very large-scale data, techniques that apply at scale. And this will be true both from the algorithm's perspective and from the statistical perspective, right? So certain statistics, if you have 10 data points, you can't really trust them, but when you get millions of data points, and you can kind of learn more interesting stuff from that data. So we're going to focus on these large-scale parts of the data analysis. We're going to try to do a broad coverage, covering kind of all the hot topic, I mean the core things that you really should know in a data mining class, but not focusing on some of the classic ones so much, in order to kind of talk about some cool recent developments. What are people using in industry kind of right now? Now, we won't be able to explain all these in full depth, but you'll get exposure to all of these. Also, this class is going to be focused on kind of formally defining what these algorithms do. And this is going to be in some mathematical notation that is common in data mining and machine learning research papers. Okay, so this is notation that many of you are probably not used to. So I will use this explicitly in the class, but I will also try and explain it as I go. And I really hope you will interrupt me if I use a symbol or a shorthand that you're not familiar with. Please stop me. If you have a question, probably half the class has the same question. But I will make an attempt to explain all of these as I go. And I've taught this a few times, so I kind of have a sense of what people already know and what they don't. But I think it's really essential to use this notation. This is notation that's been refined over years of working in this, and really clarifies how you can think. It defines a language that describes the right abstraction to see what's going on. And so there's good reason why we'll stick with this, but it may take some getting used to. We will talk about some proofs, but we won't go through them fully formally. We may go some proof sketches, but it's not a class on proofs, despite all a lot of use of mathematical notation. And we'll focus on things which are practical and are used heavily, mainly in internet companies, like at Google and Amazon and Facebook, the sort of things that they end up using. Now, these have applications elsewhere, but I'll draw a lot of the examples from things going on with inside of those companies. And so another thing which may be different for you if you're not used to it is we'll use a lot of probabilistic algorithms, right? So this will involve things like random sampling and random processes, think, quicksort, but much more kind of involved. And so this means an algorithm, every time you run it, is going to give you not only is it going to have a different runtime like quicksort, but it may give you a different answer. And that doesn't mean the algorithm is wrong, but you have to instead understanding, is this answer correct? But understand, if I run this a bunch of times, what is the distribution of answers? And kind of use that to gauge the answer to something. And that may be because, well, we don't know the precise answer, we should believe it, or because we're using this randomness to make the algorithm more efficient. And so the downside of that is that we don't get a precise answer. Instead, we get one of the many possibly answers which are good enough. Okay, so we'll expose you to these ideas. If you've taken, I believe some of this is covered in the advanced algorithms class, and the machine learning class and the AI class is a similar way of thinking. So if you've taken those before, you'll be kind of used to some of these thinking. If you haven't, some of this will be new, but we'll walk through this, and the first few homework assignments will really kind of force you to think about your algorithms in this way. We'll start with simple examples and work our way up. There will be no specific software tools or programming languages required, right? We're not going to be kind of just going through how to do all the algorithms inside of like scikit-learn. I think this would be boring for you. I'm confident that if you're in this class and you're prepared to take it, you can figure out most of how to do this by yourself. What you probably don't know without taking this class is when to use it and how to diagnose if something goes wrong, right? And there's no specific programming language. So you can use any programming language you want to. There are recommended ones. So Python seems to be a great language for this kind of dominant language. R is used a lot in data analysis, but for some things in this, assignments in this class, it will be more challenging because it doesn't have the same sort of scalability and data structures infrastructure that Python does. Java or C++ are going to work fine. For some of the assignments, they're more geared towards doing stuff in MATLAB, where it's a bit easier to manipulate matrices. Okay, so linear algebra is the most important thing, kind of a conceptual understanding of vectors and matrices and how to think about them. It's kind of, if you don't have that, a lot of the concepts you're going to see are going to be new ways of thinking about these vector data while you're also learning kind of the algorithms and the modeling aspects. And that part will be challenging if you don't have any linear algebra. The probability, you kind of need kind of a sense of these things. There's not much specific you need, but kind of when we're dealing with these probabilistic algorithms, if you don't have a probability background at all, these concepts are going to be so foreign it may be hard to pick up. And then there's going to be a lot of high-dimensional geometry. Now, I don't expect anyone to have much background in this area, but we'll see a lot of this throughout the semester as well. So I think some of this is very cool. That's one of my favorite parts. Okay, so again, to explain what is this classic view of data mining, and really I think of this not just as a classic view, but as an old view of data mining, is restricted to kind of this kind of four-part chart, right? Where you have the rows are your input data X either has labels associated with it. This could be scalar values, or they could be kind of true or not true. And then if you have labels, you either do regression to predict scalar values, or you do classification to predict binary values. Is the sports team going to win, or are they going to lose? And you do this prediction. If you don't have labels, then you try and do this either for high-dimensional scalar data. You often do dimensionality reduction, or if you're trying to build stuff into some unknown classes, you do clustering. And this just is finding the structure inherent in the data, right? So you either get the scalar outcome with the regression or dimensional reduction, or the set outcome with classification and clustering. Okay, so this is an old classic view. And if you think of it in this way, then at Utah, the classification part is basically the main topic of the machine learning class. And this class is going to stay away from that. And it may be that the regression may not be taught in some data mining classes. It may be grouped into this, this supervised learning, which is this top row. But we're going to cover regression, dimensional reduction, and clustering, these three boxes in this class. Okay. But we're not so restricted to this chart either, right? So this is going to be kind of part of it, and we're going to think of the regression, dimensional reduction kind of in the similar basket of techniques that we look at. So we're not going to be so restricted to this box as you might be in some older kind of versions of data mining classes. Okay, so what is the outline for this semester? So you can kind of see this on the schedule on the webpage, but let me kind of just go through this. We're going to start with some mathematical properties, which are kind of essential for understanding how to think about the kind of this new probabilistic high-dimensional view of data. So we'll start with these ideas of hashing, and probabilistic concentration of measure, and talk about similarities, which is really about defining distances and, say, high dimensions or sets, and what's the right way to do that. But this also, similarities also has some things that would fall outside that chart, right? How do we find duplicates of data? How do we find the nearest item to a query item, right? And then we'll look at some more classic structure and data questions. So having to do with clustering, where you aggregate close items into a similar set. Your regression, where you're really understanding linear structure and high-dimensional data or dimensional reduction. And then link analysis, which is really about large graphs. What large structure graphs, structure can you find large graphs? Say the web graph, where you put an edge between web pages and they link to one another, or some social networks. How do we deal with these large graphs? Interspersed in this will also be kind of some other topics, and I've highlighted one here, this noise in data, where we'll look for a time. How do you think about, how do you define noise in the data? What's the right way to think about that? How do you find anomalies? And also some questions that come out, such as ethical questions and privacy, which are really kind of often tied to a similar way of thinking about, similar to the way we think about noise, is how we deal with kind of the ethics of data mining and privacy of data mining often. So we'll talk about these as well. Okay, so let's go through each of these in a little bit more detail. So for statistical principles, we're going to do this by examining this array, okay, and it's going to each round is going to pick a random element in the array, right? So think of getting a new item each time, and you have a hash table, and the hash maps to one of the cells, right? Now this is a useful abstraction, although very simple, sometimes oversimplified, but is useful for things like understanding the distribution of IP addresses that's seen on a router, the words that are frequency versus all the words in the dictionary, and there are way more IP addresses or words in the dictionary than the hash maps. So instead of storing all of them, we're going to map them each to one of these random cells. Okay, and then we'll use this specific model to study a couple of properties as a demonstration of these concentration measurements, right? So the first one will be how many times we need to call this random process, where, again, each random step assigns something to one of these cells. What's the first time that we see two elements in the same cell? Right? How long does this take to happen? Right? And then the next thing, if we keep running this, what's the first time that all of the cells have at least one element in them? Right? So right before this step, maybe this one was empty, and then this was the first time that this cell was filled. Right? How long do we expect this to take? Right? And then finally, when do these all have about the same level of hits? Right? If it's a random process, it should be uniform, but it's not exactly uniform. They're all about at this error bar, at this black bar right up here. Right? And so these answers, there's not a specific one right answer to this. Right? There's a distribution of answers, and how do we understand how frequent these sorts of things are? What is this distribution? Okay, so we'll use this as kind of a primer for things, and this kind of way of thinking in this algorithm in this analysis will show up a lot of places. This specific thing, will kind of work its way into a couple of algorithms, but is not kind of going to be kind of recurring all over the place, but in some places. What we're really focused on is this mapping from data, whether it's text or graphs or just kind of a bunch of customers and attributes about them, and mapping them to abstract data types. Often this will be high-dimensional points. It could be mapping from a graph to a matrix, which we then map to high-dimensional points, or just map to high-dimensional points, or you may map these to sets or other representations. And so you can take something that's messy over on the left side here and map it to something that is clean to deal with on the right side. Now, the more mapping and approximation you do in this process, the less you retain in the modeling, but the more algorithms you have accessible to you. And so this is the sort of thing we'll focus on throughout the semester. And we'll start this, I believe, already in the third lecture, so when I get back on Wednesday. All right, so then we'll use this to kind of answer a certain amount of questions. Once we have this mapped to abstract representations, say given a large data set P, and then given a query point Q, which is of the same type as the set, what is Q already in the set? Or what is the closest point in the set to Q? Right? So if it's not in there, what's close? Right? So let's say that the data set is a bunch of essays people have used for grad school applications. That there's online databases of these. I'm sure many of you are aware of this. And so we can run these essays against this database and see if it exactly matches one, or maybe you change a small amount. So we find the closest one in some sense of distance, then we can kind of say, okay, they basically copied the same thing, right? And so in order to do this, we need to think carefully about how do we define the distance between these, and then how do we do this efficiently. And so these will be the sortations we talked about. Next will be clustering, which will be finding groups of similar data. So when do we need a kind of, and there are lots of versions of clustering. There are so many different versions. We'll try and cover like some very general sense of some kind of very heavily used things which are close to the state of the art, and which cover maybe 80% of the types. There's a whole class like clustering and so forth, right? So, and there are various, do we need representative for each cluster? Can the groups overlap? What structure, distance do we use? So we'll focus on these higher collaborative clustering, these k-means type of clusterings, KBD and k-means++, and clustering on graphs as well. And these all have different sort of properties. linear subspace or pattern that represents the full data set well, or some pattern mapping to some scalar values well. Right, so we'll talk about a variety of techniques. We'll review kind of standard least squares, L2 regression, and PCA. Each of these will be about a lecture. Right, so if you've seen these before, we'll review them quickly. If you haven't seen them, we'll go through these quickly. Either way, hopefully you'll stay engaged. And we'll talk about other more advanced things as well, such as multidimensional scaling, matrix sketching, which is how to do this at extremely large scale, L1 regression or orthogonal pursuit, which is more robust to outliers, and has other nice sparsity property, which is really cool. And this idea of recovering information from the data, such as using ideas from like compressed sensing. So we'll touch on a lot of these kind of more advanced topics beyond kind of the basics, which we'll go over more quickly. Okay, then noise in the data. We'll talk about a variety of things. How do we find and remove outliers? What does this even mean, right? This is kind of a trickier question than you might think. It turns out there may not be a really good answer. How do we model the noise effectively, and how do we exploit the noise? Differential privacy is the approach we'll talk about that ensures privacy of individual kind of data points, which can be customer, by adding some small amount of noise to all of their data values. How do we do this while retaining the overall structure or prediction? And this ties in a lot very closely to the ethics of data science. Can we do this to exploit an underrepresented population? There are lots of kind of sticky issues here that you really should be aware of if you're doing data science. This is really coming to the forefront of like what people think of, and very quickly. If you want to be a responsible data scientist, you need to at least be aware of thinking about that. So, and often be aware is half the battle. So we're going to cover everything, but I will try and expose you to some of these issues. Then finally, we'll cover link analysis and graphs. And really, one way to think about this is, how does the Google PageRank, Google search algorithm work? Why is it so much more effective than the other algorithms that came before? And we'll walk through this by kind of starting with Markov chains, talking about PageRank, how they scale this through macros. And we'll not just talk about the mechanisms of these, which you may have seen in the linear algebra class, but also kind of the history of how they evolved and kind of the battle between spammers and search engines, which is this kind of is represented in many online battles between various factions with different goals. We'll also talk about some other graph structures, such as how you find communities in graphs, how you find the most important nodes. We'll talk about a few of these. Okay, and then mixed in through this, like this matrix sketching I mentioned, we'll talk about some techniques to do this at a very massive scale. So these are often streaming algorithms or dealing with kind of these, how to quickly represent complex distributions through quantiles, and a variety of these issues. And these will kind of be mixed in throughout the semester. Okay, so just to summarize, the goals for the course are really to help you build an intuition and kind of a set of principles for doing data analytics correctly. It's not going to be so much hand-holding and walking through a software package, but you will get to run and see how these algorithms work, not just on one data set, but on kind of like these noisy data sets where you have to actually think about the answer, not just run it and, here's what the answer is. Is that a good answer or not? And then we'll also talk about how to model these data. How do you convert it to the right abstract data type? This will be a theme that comes over and over again. And then once it's an abstract data type, how do you process it efficiently? And then looking at this trade-off between how abstract you make it versus how efficient, which allows you to be more efficient potentially versus how carefully you are modeling the data. see you, so Sunitha will lecture on Wednesday, and then I will see you the Wednesday after that after 1:30. Bye.
Okay, so do you have any questions that I can help you answer? So one thing I want to say is today I didn't talk about a lot about project. So if you are still want to know more about like what are the expectations of the project, one thing you can do is try to I think go to the first video of the previous semester. I think the first 20 minutes of the first lecture from previous semester, Jeff talked about the expectation of the project and what are you supposed to do for each individual intermediate deadlines. So I'm sure when Jeff comes back, he will also talk about this one more time as we're approaching project deadlines. But if you are curious from now and if you want to make a decision whether you want to choose this course or not, you can just take a look at there. And yeah, so I hope today's lecture can help you decide whether if you want to take this course. Yeah, so if you have questions, just send us emails to either Jeff or TAs. And if there's no questions, I think that's it.
Yeah. No, I did.
To wait, so when they edit it later, at least they know you care.